Included in ASAP 2013 are expansions to the CIE feature to allow you to calculate tristimulus values using either the 1931 2-degree standard observer model or the 1964 10-degree standard observer models, as well as to calculate XY chromaticity values using the 1931 color appearance model. All of this data is stored in a standard ASAP distribution file, and this information is available to you for further analysis with the goal to allow you to evaluate, manipulate, tabulate, and visualize the colorimetric properties of your source at any part or subset of your system. So let's take a look first at how it affects the ASAP command structure. Some of the features available that you'll need to take into account when you wish to do this type of analysis is there's now an ability to set a maximum number of CIE configurations. What this will do is set aside memory space, and when you do your ray tracing or perform your analysis, you can choose to store that in more than one set of CIE configurations. So in this particular case, we've set the value to 5, so I could save 5 distinct sets of data for colorimetric analysis. We're not going to do quite that many, though. The other thing is when we choose to do our analysis, what we need to do is to define our new CIE set. In this particular case, we're going to base it on the 1931 observer model. And then we can do irradiance or intensity calculations. But again, we will also be able to get tristimulus and chromaticity data as well. As I mentioned, this information is stored in a standard ASAP display file, and then I can read in that information and visualize it or take a look at the numbers or do whatever type of processing I wish to do on that information. So let's take a little look at some analysis that I've already run. I simply have, using our new polychromatic source option, defined a black body source. I created a simple surface in ASAP, turned that into an emitting object, and I'm going to use that as my baseline source, and then I will create ray distributions over the wavelength interval of 380 to 780 nanometers. Now, right now, you'll see my file is set for a 6500 Kelvin black body, but I've done 2 sets of analysis, both with the 6500 Kelvin black body as well as a 2800 Kelvin black body, and we simply look at the CIE output for that as well as the result of opening up the display calculation. Now, when I do this chromaticity calculation, for each CIE configuration I've established, what I'm going to do is to create a distribution file that has effectively 5 pages, if you will. The first page is going to be the X tristimulus, the Y tristimulus, the Z tristimulus, and then the X and the Y chromaticity. And for this analysis, I'm just going to take a look at those. But let's start with a 2800 Kelvin black body. And let's look at a standard CIE analysis. And you'll notice that the RGB intensity is somewhat an orangish, brownish type color. Reason I picked this particular wavelength is because last night I was at an elementary school talking about brown dwarfs and cooler types of stars, so this seemed like an appropriate color. But again, matches what we would see in our area here. We are right on the black body locus because we did define a black body, and we can see the RGB intensity values here as well. But again, we sort of have this orangish color, matches what we see here. Now, this is the location on the locus of points for our Planckian curve, and I might want to know exactly what are those X and Y coordinates, and I could come down here and try to interpolate off this graph. But instead, what I'm going to do is look at the results in my display file. So if I open up the Chromaticity X display viewer, what I see is this output here, and you'll notice my X coordinate is 0.452. My Y coordinate is about 0.409. And if I come over here and look at this data point, we can see that this is indeed about 0.452, and this is approximately the 0.409. So we can see a consistency between the data. And again, all of this data is available to you in either graphical or numerical form to get whatever information is appropriate. And simply as a change, I now have a 6500 Kelvin black body, which to us appears to be quite white. And again, here is its location of all of the concentration of this black body. Again, the same 81 sources over that same wavelength region. And if I want to get exactly what the X and the Y chromaticity coordinates are, I can simply look at my display file, and my X chromaticity coordinate would be 0.314, and the Y chromaticity coordinate is about 0.324. So among other things, what this will allow me to do is, using the new ASAP polychromatic source model, I can define a polychromatic source in any method that I would like. Case of a black body, it's straightforward, but then what I could do is immediately do a chromaticity calculation to ensure that the data, the functional form I provided for that source, actually matches the energy distribution or the colorimetric distribution of those sources. And that's a little bit of information about the new CIE and chromaticity calculations available in ASAP 2013.